Good afternoon, everyone. Welcome to this Massons Digital Webinar. And today we'll be discussing building a CAD/CAM service model in O&P. So in a moment, I'll pass over to Lewis, who'll take you through some pathways into CAD/CAM, what you need to start considering this in your practice if you're not already venturing down that route.
Good afternoon, everybody. Thank you for joining our third webinar in the Massons Digital Series for 2025, building a CAD/CAM service model in orthotics and prosthetics. So today we will be talking about the traditional O&P service pathway in Australia, what that looks like, what's changed, and why CAD/CAM. Go through some of the advantages of digital workflows, as well as what CAD/CAM pathways that we can take. And then we'll also go through the basics of setting up a CAD/CAM enabled practice. So the minimum requirements you'd need and some general clinic workshop basics and tips and tricks. So we start talking about the traditional O&P service model in Australia. So say for most of the profession's existence, it's been a self-contained service. And by what we mean by that is that clinicians will assess, prescribe, modify, and fabricate everything under the one roof. There may be in-house technicians on staff to help increase the volume of fabrications or to do stuff that's more technical, but still under one roof in a traditional service model. This does lead to normally significant wait times, and if not in fabrication, can even be in appointments as well, because again, everything is under the one roof. It all relies on everything working in cohesion to be efficient. Physical casts need to be stored on site if device repeats are desired, and so that is something that takes up space in a lot of traditional styles of service. And the different devices that you can actually prescribe can be limited by what you have on site to fabricate with, as well as the technical experience of either yourselves as the clinicians using stuff that you might not be familiar with, or technicians using certain components or materials. So what's changed in the industry? Overall, there has been a growth in population and practitioner numbers. Australia is still underserviced compared to other developed nations, but the profession has still grown quite a lot, and so the market has grown commensurate with that. The introduction of things like the NDIS really changed the game, making it easier to provide remote services and let patients choose their own area of care. That does involve more paperwork and red tape to navigate around. Overall, what this has meant as well is that clinicians have less time to spend fabricating than they used to in the past, when it was a lot simpler to prescribe and fabricate. Now there is a lot more paperwork and funding approvals and things than there used to be. Over the last while, there have been developments in technologies and fabrication techniques as well. So there might be specialized knowledge and training to do certain devices. Some facilities as well have some restrictions on what materials they can use. I've heard of no carbon fiber in some places due to OH&S risks. So where we have had these developments as well, which have changed what we can fabricate, but potentially not just what we can do, but what we might not be able to do as well. These factors combined have led to a huge growth in the demand for central fabrication. So the idea of looking at ways to offload your work externally. So with all these changes, where does CAD/CAM really fit in the industry? Well, CAD/CAM has been in use in O&P for over 30 years. It's not new by any stretch. When we're talking about CAD/CAM workflows, this isn't something in the last couple of years that's really changing the game. It's actually been around for a long time. For 30 years, it's a long time. So what's changed? Really, with any kind of technology, it gets improved as it's tested over the years, and it gets a lot cheaper. And so these days, there's more options to engage than ever before. So CAD/CAM has been, or even has a reputation for being something that can be quite expensive to get involved in, but that has completely changed. And even in the last few years, technology is just getting cheaper and cheaper, and more options have been available. So we've got a wider net than ever before to look at different options. Something I'd also like to note is that online presences and social media, we're seeing clinicians share their skills and experiences. So rather than just needing to go to conferences to see what's new, we can see these updates happen live. Especially when it comes to CAD/CAM and other uses, being able to screen share and easily show different techniques is just another way that the industry's changed. So why bother with CAD/CAM? Really, at its core, it's intended to save time. And so we're not trying to reinvent the wheel. CAD/CAM isn't trying to completely undo your clinical understanding. We are just trying to leverage your knowledge in ways that are faster. Because at the end of the day, saving time is saving money. Good CAD CAM systems, they're capital investments. We need to use them to pay them off. If you don't spend the time to learn and use them properly, you've bought an expensive paperweight. It's going to sit there and not do anything, but just look expensive. With that being said, you can wean into using CAD CAM without needing to jump all in. So you don't need to necessarily think about, oh, how am I going to transition from all of the traditional techniques I know completely to CAD CAM overnight. You can do one thing at a time and wean yourself into the process and get used to it without having to transition overnight. As we're trying to save time and money, we do require an investment in both these things. So we need proper time to learn and implement new technologies, or it's just a waste, really. So like any skill, practice is key. So yes, there is an outlay of money, not necessarily depending on some things we'll talk about, but in general, you might require to put down some money, but you need to put in the time. It is an investment in both. How does it really benefit our industry? Well, aside from the time factor, one thing that's really useful is that it lets you access services that might have been difficult to engage with in the past. So things like CFAB are a lot easier to engage with if you can send a scan rather than having to ship a lot of plaster, which is heavy, expensive. I couldn't tell you how many times I've opened up shipped plaster and just seen it smashed. So CAD CAM makes it a lot easier to engage with these kind of services. One of its main benefits is reducing the need for repetitive physical labor. So you think about filling casts, modifying plaster. Sometimes these processes, you can almost turn the brain off if they're the same thing day in, day out. So we're trying to reduce the amount of time spent doing that, as well as OH&S risks. I think most of us in the industry have tried lugging around a massive mold of plaster, and it is unsafe, it's dangerous, it's not good, not just in case you dropped it, but your back and everything else. So CAD CAM has a lot of benefits around even that side as well. And of course, with time, what we're really doing is freeing up time for you, the clinicians. So you've got more time to complete all of this new mandatory paperwork, but also with that, you've got the potential to increase your patient caseload depending on how much of those repetitive tasks you're able to either speed up or offload. Some other advantages of a digital workflow, well, ideally, less workshop space. If you're doing a digital workflow, you don't need to store as much on site and you don't need as much equipment, especially if you're utilizing central fabrication. One great benefit is if you like having nice shoes or nice pants, wear them to work because they're not going to be covered in plaster anymore. So that's cleaner not just for yourself, but also for clients, especially if we're using more fiberglass in cases of casting rather than plaster. Ideally, we'll end up with reduced wait time, so devices can be fabricated in weeks instead of months, and sometimes even days, depending on the workflow you take. And central fab as a primary or backup option can further assist with reducing these wait times. So that's, we're always talking about time and money. Being able to get devices on people quicker and more efficiently is always going to be a benefit. And a really handy one is the digital shape archive. I would imagine nearly everybody watching has broken a cast and knows the shattering feeling that makes you have inside because you have to start all over again. With a digital workflow, especially beginning with a scan, if something goes wrong, you've got the shape on file, you can start again. That doesn't just make it easier in case something goes wrong, it's easier for repeats or slight adjustments. You don't necessarily need to store an old cast to fabricate a new device or fill something full of alginate. We can reuse the digital shape archive. It can be also really good for comparing before and after because we have this digital record. So that's a lot about the benefits of digital workflows, and especially when it comes to time. So when are you going to see those results? Well, it is really important to notice that in almost any aspect of a new workflow or a change up, there is going to be a drop in productivity. And that's something that you should be prepared for and keep in mind because you're not going to be star off the bat smashing out the numbers that you are clinically now. It is a weaning process in. Because as your experience and your knowledge increases, that productivity drop begins to stabilize and then ideally begins to improve as you master these skills. So that is also why it's an investment in time and money, is there is going to be that little productivity loss before you manage to get up to speed and then beyond. Because once you spend the time to learn, the process becomes second nature, your productivity is going to soar. It might take you over an hour to do your first digital modification, and then it might be taking you 5 minutes by the time you practice. These benefits really come from how much time and effort you put into it, and how long that productivity loss takes to balance out and get better does depend on how much time and effort you put into it. It's reiterating that this is an investment. You need to be putting in the work to get the benefits out of it. And once you do, you're never going to look back. The CAD-CAM pathways, there's a lot of different ways that CAD-CAM can go compared to a traditional pathway. So a normal pathway, we'd go hand cast, you fill and modify the plaster, and then you pull some foam on it, do a plastic draper or lamination or something along these lines. It's a pretty straightforward linear pathway. Versus CAD-CAM branches out so much further, and there's a lot more avenues that we can take rather than just the classic. You can also use CAD-CAM end-to-end, so straight from scan all the way to final device without even so much as touching a physical thing, or we can just use it partially, depending on where we want to do in the process. Also, multiple pathways can be leveraged simultaneously, so you can really start to branch out beyond the capacity. Like, you can do a traditional fabrication, say a carbon fiber laminate, at the same time you're 3D printing in a boot. And these things can be done at the same time instead of needing to be one after the other, because we can leverage those pathways. So when we talk about pathways, really we're talking about this process from input, design, to output, and then to fabrication. So there's a bunch of different ways that we can take this. When it comes to input, regardless of what kind of shape capture you have, everything in CAD-CAM needs to begin with a scan. So this could be a modified plasterwork that you're going to scan to send. It could be a fiberglass cast or a live subject that you scanned, or it could be an impression. Whatever method of input you have, a 3D scan is going to be required. Then from that 3D scan, we take it through to design. We can do in-house modifications, so adjusting size and angles and build-ups and all of that ourselves, or we can move that externally and have that done by another provider. In the same vein, we can do that for 3D shell design. So we can go do some 3D shell designs in-house or externally 3D design. Regardless of how we design, we're going to end up with a digital file. Potentially that could go straight to a foam carving as well. So depending on the workflow you're going to do, the file or the carving might be your next point of output. From that, we're going to have our fabrication. So our foam carvings are going to be for in-house traditional fabrication or central fabrication as well, because we don't have the plaster, so we need to take that model and have it turned into a physical thing, which is where the carvings come in. We do also have the options of in-house 3D printing and external 3D printing, which would remove the foam carving entirely. So we're going to go through these ones as well and break them down a little bit further. Starting with input. All CAD-CAM workflows have to begin with a 3D scan, with the one exception, designed by measure. But in general, if we're talking about custom patient-matched devices, basically anywhere you need a cast, you would need a scan. You can scan patients directly or scan an impression. So it really doesn't matter how you get the shape capture, so long as you get it and that it's a clean cast or impression. Garbage in, garbage out. The better input we have, the better output we're going to have. For that reason, we would always recommend scanning against scanning the exterior of plaster of Paris cast, because the surface thickness is really hard to get consistent. Fiberglass is a lot easier to get a consistent thickness, which would be an accurate reflection of the subject. That being said, while we're aiming to try and move away from plaster with CAD-CAM, scanning your modified plaster work can be a good start to engaging with CFAB and trialing that out. As we mentioned earlier, shipping casts expensive because it's heavy, risk of breakages. Scanning modified plaster is a really good way just to get started into looking at what else is out there. So talking about 3D scanning, there are so many options out there, but in general, you get what you pay for. The accuracy and the ease of use comes at a cost. Like iPhone scans, they're the cheapest and easiest way because they actually don't cost you anything if you already have an iPhone, but they're by far the least accurate and the trickiest to use. So we're starting at the lower end, cheap, but you can knock it out, test the waters, and find the limitations where you're going to then move to another type. Handheld white light scanners have been identified in the literature to be the most recommended type of scanner for orthotic and prosthetic applications. Infrared is still a viable scanner as well, but when especially it comes to really high accuracy applications like cranial remolding orthoses, handheld white light is the best standard that we currently have. When you do purchase a 3D scanner, like we'll reiterate constantly, investing the time to learn and use it effectively, it is just as important as how much it costs you. We don't want this to be an expensive paperweight. You want to buy a scanner and put the time into using it to the point that you should be able to scan like it's second nature to you, just like your hand casting. If you want more information on 3D scanning, you can view some of our previous webinars where we've covered this topic in more depth. It's available through the Massons Education portal or directly on our YouTube channel. So when it comes to design, well, plaster room no more. At least that's what we're ideally trying to get to. So the easiest way to understand a digital design workflow, we'd start by translating your experience of physical plaster into digital. That can be one of the easiest ways to get there. We can start playing around with changing up the order as you get used to CAD/CAM, but pretty much doing a virtual plaster room is one of the easiest ways to get you started. There's several different types of software you can use, and they could be yearly licensing fees to pay per output or anything in between. There should be an option that best matches your needs and your budget. Normally, pay per output is very useful, especially on a lower volume, versus yearly licensing can become quite cost effective if you have the volume to back it up. So there's sort of three main types of software that I'd like to touch on. We've got a general CAD software, so stuff like ZBrush, Fusion 360 or Blender. They're really powerful softwares with a really high skill ceiling. If you don't have experience in these programs or you don't really have an industrial design degree, they can be quite hard to pick up and use, but they're super powerful if you know what you're doing. For our industry, especially in Australia, what we see more often is O&P specific CAD software. And that's designed to match your existing knowledge, often using terms you're familiar with. Like instead of bending, it might be plantar flexion, dorsiflexion specifically. It uses APML instead of left and right, like all the kind of terms that you're used to, O&P specific software uses. So stuff like Omega, CADMet, or VoxelCare, they are tailored to work with your clinical knowledge already. The third time that's really come out in the last little while is what I'll call a click-through solution. So something like Leopoly or Ugani, where it does a lot of the heavy lifting for you. But because of that, it's less customizable. Like they're very powerful and they do a lot and they're really quick, but you have a bit less choice over how they work, and they can really struggle if you don't have really good input. Like an example is if you've got a tourniquet cast, these softwares cannot really smooth that out. They rely on really good input to get a good outcome, which is ideal, as we say, go garbage in, garbage out. We need good input. But for some like Omega or even the other softwares, we can do a bit more to the input than we can with some of the lower. So it's that trade-off of simplicity for how much you can do. Speaking of, when we're talking about doing modifications in-house or externally, regardless of what you do, that good input is key. If you're working on this in-house, it puts all the responsibility for shape and device fit on the clinician, so very standard to what you'd be used to working in plaster. That being said, I'd always recommend taking a set of patient measurements for quality control. There are clinicians out there who can take a plaster cast, fill it, and modify without so much as picking up a tape measure, and that can be done in CAD/CAM as well. But that being said, it's always something I'd recommend you having, because you should never assume that everything is correct. You'd rather have it and not need it than need it and not have it. And several CFAB services offer modifications on your behalf. So instead of you needing to do all of the design work, a way to save time is to handball that off to another provider. So some like Massons, we offer a digital design service, but we can also work off modifications you've already done yourself. Other services like the Tali helmet from Invent, they actually require that they have a raw scan so they can do all their own internal processes to it. So depending on your provider, you might be able to engage with your own mods, or they might have their own requirements. Either way, it's good to have communication with them to understand. When you're using external modification services, it's really handy if you'd have thorough documentation. Know your measurements, your alignment, range of motion, and a really clear prescription, and a clarity of the needs and expectations. So you want to make sure that the way that you think about something is the same way that the CFAB thinks about it, or at least that you're on the same page as what to expect. And that good communication is going to go a long way. And especially if you're not able to duck down to the workshop and ask something, you've got to have a really good communication with an external provider. So following on from the modification and design, when it comes to the fabrication of traditional devices, and when I say traditional, I'm talking about typical thermoplastic and laminated devices. For most of them, mold is required. So unless you're carving directly for a shape like EVA foam insoles, we normally need a mold to work off of. And so shapes that have been modified digitally, they're carved out of polyurethane foam. It's significantly lighter and safer to handle than plaster. Like, the different. I couldn't even tell you the factor, I think, top of my head, but the difference is night and day. It's quite easy to modify. You can surform it. You can add some plaster to it if you need to. In some cases, you can even stick the foam together. So it's very easy to modify if you need to. That being said as well, there are some differences with working on plaster. So compared to working on plaster versus working on foam, so maybe chat with your carving provider for some fabrication advice, especially if you've never done this before. Sometimes the foam just behaves in a little bit of a different way to plaster, so you'll just need to change up your process a little bit. But there are several facilities out there working purely on foam and having no issues. One thing to consider though, is we talked about time and money. Shipping time is a factor to consider. And so that's both for if your carving is in-house or externally fabricated devices. If you're ordering carvings off-site to then fabricate in-house, you need to factor in the time that it's going to take for that carving to be made and shipped. But that being said as well, if your production volume is high enough and you're working purely in a digital workflow, that's when you can start considering investing in an in-house carving robot. So you no longer need to be waiting for somebody else to carve and ship, which even though that can be a turnaround of just a couple of days, if your volume's high enough, you can really start pumping out these molds and having all of that internally under the one roof. External fabricators are very useful, especially when it comes to traditional fab and fabricating with materials that you either don't have or components you don't have experience with. Especially these days with certain funding applications and getting your new shiny and functional components, if you've never used it before, it could be very daunting to pick it up and put it into a device. So you can leverage external fabricators who have that specialized knowledge to do that for you. Can also be useful even just for easing up the workload if your workshop is busy. You know, we love technicians. They are absolute unicorns and highest pedestal in our industry, but they can only do so much. There's only so many hours in a day, and there are times where things get busy. So even if you've got a very well functioning in-house tech team, CFAB can be useful as just a way to offload some of that pressure, especially in busy times. So outside of traditional fabrication, we've got 3D shell design. So when we come to 3D printing, we're removing the entire aspect of the workflow, the mold. Like we don't need plaster, we don't need foam. We're effectively taking a scan, modifying that, and then creating a shell around it to print. These days, new materials like the PA11 that we use at Massons, they've got proven strength and reliability. Like gone are the days of basic 3D prints that are going to shatter within a week. We have materials that we know are going to last and provide the same amount of support that users and clinicians are used to. And with that being said, we can think beyond our traditional manufacturing techniques because we're in that digital space, and with things like our PA11 in the MJF printer, essentially the sky's the limit. If you can picture it, we can design it, or you can design it and it can be made. So we've got all of these avenues opened up that haven't been possible before. So it can be a challenge to start thinking about, especially if you have a tricky case, what would you like to do, not what can you do with what's available, because we have all these new options now. Like the modifications, there are several design softwares that we can use. So some, like I mentioned earlier, like Leo, Poly, or Ugani, they work by applying a set design template to your shape. Others like CAD give you a lot greater control over the customization. So you can really take it to the next level in terms of your 3D designs, but they're still quite intuitive to your clinical experience. General heavy-duty software like Fusion, as we mentioned earlier, they can absolutely be used for 3D shells as well, but it's a massive learning curve, especially if you're getting into CAD the first time. If you're a well-experienced user, fantastic. If you're less experienced in trying to get into it, Leo, Poly, Ugani, or CAD can be some good options for you. Being said though, if you are designing stuff yourself, you've got a significantly greater risk of weak spots and breakages, especially if you're less experienced in the design. Like utilizing external services can give you some more confidence that your design's made to last, because the fabricators, potentially like Massons, have some experience in designing these, so we can pick out things that we know might fail based on experience. An example here, like this pink AFO on the bottom left, the Invent Medical Piro AFO, that had over 500 separate iterations before it's ended up here. So definitely leverage the knowledge of the other providers, especially if this is something you're trying for the first time. So that's about the design of 3D prints, but what about the actual fabrication? Well, in general, we'd say 3D printed devices turnaround can be much quicker, with the caveat that it really depends on your printer speed and the capacity. So like FDM, your traditional layer by layer out of an extruder does one bed worth at a time, versus MJF or our powder prints are done in batches, so we can do multiple devices at once instead of one at a time. They may require certain post-processing methods, so sanding, painting, vapor smoothing, whatever that is, it is just something to consider as well. And the in-house printing, it can be cheap and easy for basic stuff, especially like insoles. The printing can be quite quick and quite reliable, but potentially the printing, especially if you're using like hobby grade stuff, it can take a really long time and might need significant post-processing the more hobby grade you get. So there is that trade-off. If you've got a really great printer that prints reliably, it can be super simple. You could get insoles done same day, no worries. Otherwise, it might take you a bit longer. We do have some other options available, stuff like the Feet Needs continuous belt printer. They print on a belt system and work around the clock. So as opposed to needing to do one bed at a time, break a model off and start again, it just continually runs it through on a conveyor system. So you can literally set and forget and let it go overnight. So there are solutions out there to try and increase capacity as you grow. And of course, the other option, it can still be quick, is to externally fabricate. 3D printers, one of the great parts is you pretty much just hit go, let them run, and then do whatever processing is required. This is a slide that we've used in a couple of the webinars, but it is just to show you a bit of an idea of the various CAD/CAM pathways at Massons. So depending on your input and your type of shape, we've got so many different ways of achieving your goals, a lot of different software options, and a lot of different fabrication options. Essentially, whatever it is that you want to fabricate, or however you want to engage in a CAD/CAM pathway, at Massons we have a lot of experience working around this for all kinds of different scenarios. So we're always open here to answer your questions and help you with this kind of workflow. So to give you some keys to success with all the digital workflows, reiterating, good quality input is a must. Garbage in is garbage out. We need good input for good output. I always recommend checking your measurements. Digital scale can be deceiving, especially when you're looking on a computer. It can be hard to get a sense of scale, even if you do have the appropriate measurements. So just double check. As I said, taking the measurements, rather need them, have them and not need them, and need them and not have them. So prime example I have once was working on a cast where there were no measurements provided. I got nearly all the way to my end result and realized that it was half the scale that should have been, because I hadn't checked measurements prior. And that was a learning experience for me to just not take the scan as gospel, to do some quick checks against basic measurements. The only measurement I had on me at the time was a foot plate length. So when I measure my thing and it comes down half the size, you realize something's wrong. So do those checkings, never assume that everything's perfect. Whenever you go into a digital workflow, have a clear understanding of what you're trying to achieve on the other end. If you just jump in a bit willy-nilly, going, oh, I just want to do some general stuff, it can be very overwhelming. It can be very cumbersome. If you have a set idea of what it is that you're after, we can help you find the tools to get there. And that works the same with a clear prescription. It's the same concept as that. We don't want to go in and go, oh, I just want to make an AFO. We want to understand what we're trying to achieve, and then we can break down what we need to get there. Spend the time building trust with external providers, regardless of who they are, and embrace the collaboration. Especially a lot of external providers are used to digital workflows, and you can leverage their knowledge and experience. In the same vein, your colleagues, friends, anyone who's tried these, leverage that knowledge. And you can also try out novel designs without having to invest in something yourself. Even if you are not ready to jump into CAD/CAM yet, but you have this crazy 3D print design that you want to try, contact external providers, chat through it, because even though you might not be doing any of the CAD/CAM directly yourself, other than maybe a scan, you can start seeing how that process works and hopefully get some little wins that improve your confidence. When you are dealing with external providers, clear communication is absolutely key, as well as understanding and managing the expectations. You are offloading work, so there does need to be a really good understanding of what both parties are expecting. Good quality input and scan, measurements, and prescription are absolutely vital. Versus, don't just throw a scan at somebody and expect to get gold. You want to give them the biggest layup so that they can make the slam dunk because they had all the right setup. And as I say here, thorough notes and designs. Be as clear as you can. It absolutely always helps. So we're talking about getting started with setting up a CAD/CAM practice. If you're starting from scratch, scan to fab workflow using CFAB services is by far the quickest and most cost-effective way to launch your practice. If you're not having to fabricate anything on site yourself, you don't need nowhere near as much workshop equipment. If you have an existing practice though, and you're looking to integrate some CAD/CAM, I'd suggest identifying your biggest service bottleneck. So wherever it is that things are backing up, that can be the best place to start looking at where CAD/CAM integrates. So like if you're spending a lot of time modifying simple devices, are you doing the same AFO mods or the same prosthetic mods over and over again? You can basically do them with your eyes closed. Well, maybe try leveraging some digital software to make that process even faster. Or potentially, your fabrication time is just chocked up. You've had so many approvals come through the door that you just can't keep up with the amount of stuff. Then maybe try leveraging CFAB to ease the workload on your clinicians. Scan plaster or scan some casts, start offloading some work, as it might be able to help have some good flow and effects in your clinic down the line. Some basic things to consider. First is, what is your patient demographic? Are you seeing orthotic patients, prosthetic patients, or both? And that's mostly because there's certain device types that require specific scanners and potentially specific software. It's really good to know what your demographic is because it can help inform the best choices for your money. Consider as well, is your clinic in a permanent location or is it mobile? And if it's mobile, how much weight and space can you comfortably take with you? If you're constantly going on the road, having an enormous amount of equipment or a very bulky scanner or a giant computer can become cumbersome. So where your clinic is based can help inform as well what your best methods are. Same vein, how much storage space do you have or need? So if you have potentially a clinic where you've got 1 day a week in a certain location, do you have the capacity to store some basics on site? And how are you going to make modifications to a device on site? In terms of heating it up, adjusting edges, what is it that you're going to need to do some basic trimming? So really, when we break it down to clinic and workshop basics, this is just a smattering of clinic basics. It's not necessarily a covering be-all, end-all, but essentially it's saying if you have a scanner, a good laptop, a place for patients to sit, and a capacity to cast them, that is your absolute basics for getting set up with a CAD/CAM enabled practice. You notice that we don't have any plaster here because we are trying to eliminate plaster. So fiberglass casting is fantastic if you're trying to maintain position of a patient, or if potentially you're going remotely and you need to do a bunch of appointments back to back, you can always cast and then bring them back to wherever your scanning setup is for later. We recommend on the bottom here, you can see a good quality camera. Most modern phones are fine, but especially when you're starting with digital workflows, having photos as reference is always really useful. When it comes to workshop basics, a small bench grinder or socket router and associated tools to trim up the edges is going to be necessary. So there can be some standalone units or small bench mounted ones, but you're going to need some kind of grinder. Ideally, a glue station / fume cabinet, if you can get one that works as both, great. In a well-ventilated area if possible, because you will likely need to be using some glue. Same small oven and heat gun for heating adjustments, and if you can fit one in, of course, a little sewing machine is going to do you wonders. One thing I have seen done before, especially if there's a lot of mobile clinics, get out a van, especially if you're doing this for the first time. If you can fit a little workshop in or a little clinic and you can cart that around, it can be a really, really good way to move things around without having to worry about picking it all up and setting it all up each time. So some keys to success, once again, when you're setting up a CAD/CAM practice, and we'll put this into 2 categories, clinical foundations and smart financial setup. So for your clinical foundations, if you're setting up a CAD/CAM practice, prioritize adjustments and patient care over making stuff yourself. You can see more patients by outsourcing fabrication where possible. That's going to help money come in because you have appointments and you're getting stuff out the door rather than worrying about making everything yourself. Always, we would recommend invest early in a high quality scanner. It is just going to save you a lot of time and frustration. Not that you need to shell out tens of thousands of dollars immediately, but there are so many options out there now that you can get in with a smaller capital investment and they will pay themselves off quite fast. We'd absolutely recommend collaborate with CFAB providers when you're getting started. You would not be the first person to start a CAD/CAM practice. There are several that are set up and operating in Australia right now. So there's a lot of experience out there to leverage. When it comes to your financial setup, secondhand equipment wherever you can. There is almost always something going up for sale. So keep an eye out, especially when you're getting started. And it's always a handy idea to start with secondhand equipment and then potentially upgrade as you need to from there. You can always leverage payment plans through asset finance. Consult with your financial advisors about this, but if you haven't considered it before, it can be worth chatting. Depending on who you're working with, you may have the option to hold componentry on consignment, especially if you're using the same kind of things over and over again. So if that's possible, hold them on consignment. But in general as well, you don't have to have as much on hand if you leverage central fabrication. So if you're doing very similar things over and over, there's no need to keep a bunch of basic check socket locks on you if you just get your check sockets done through central fabrication. So you can leverage CFAB not just for the device, but for not needing to have the kind of materials to make everything on hand. So to conclude all the main points, a full CAD-CAM service model is absolutely viable within the O&P industry, and we have seen that been happening in Australia over the last decade. You can start your own clinic without having to invest in a whole workshop and clinic space worth of equipment. You don't need $500,000 to build out a whole workshop. You can get a scanner, a workstation, and a small little clinic space and be immediately set up and ready to go. The overall goal of CAD-CAM here, we're saving time and money by reducing the time spent doing repeatable tasks. Yes, there's so much fancy stuff we can do and all this other design, but really at its core, we are just trying to speed up the process, and that's what CAD-CAM is. It should be time efficient and repeatable. But that being said, the benefits are only seen with continual practice and patience. You will not go flying out of the gate being anywhere near as close to efficient as you are by hand. You've got so much time practicing techniques. We're not reinventing the wheel with CAD-CAM, we're translating those skills, but that translation takes time. Reiterating the point, embrace collaboration and good communication with CFAB providers is key. We're an industry that prides ourselves in our collaboration and sharing of knowledge. Leverage that as much as possible. It doesn't just have to be conferences. A message to somebody when you see a cool design can always go a long way as well. And strong relationships with external providers, it lets you offload work with confidence, so saving more time and money. You might dip your toes in CFAB by starting, say, to scan some modified plaster and then see how that goes, or then doing some digital mods. And you might even hit the point where there are devices where you are more than happy just to take a scan of a cast or patient, fill out some details, and send that off and get something back that you're confident with. And that happens with strong relationships that are built over time. As we mentioned, you can with CAD-CAM, you can integrate it into any part of the workflow. So no matter if you want to jump in completely, jump in the deep end and sink or swim, or you want to leverage it in, there are so many different options available there. In general, that concludes the content of this webinar. If you would like any further information or want some help transitioning to a CAD-CAM practice or setting up, the Massons team would absolutely love to be there to help you out with that. So you can reach out to us at info@massonshealthcare.com.au, and we're absolutely happy to help you through anything relating to CAD-CAM, starting a business, or anything in the other webinars we've presented. Thank you for attending our third webinar in the series. I'm just going to jump back to this one here to let you know that the recordings for the first two webinars in this series are now available on the Massons Education portal and our YouTube channel. The recording for this webinar should be available soon, and a reminder that the final webinar in this series, software for 3D design, orthotics and prosthetics, is happening on Thursday, October 9 at 3 p.m. Massons will also be at the AOPA Congress next week, where I will be presenting a presentation called Garbage In, Garbage Out, How to Get the Best Outcomes with 3D Scanning, which will go into some of those tips and tricks for 3D scanning a bit more as well. And that will be at the 3:30 afternoon session on Friday. So thank you all once again for attending this webinar, and I'd like to open up the floor to some questions. A question from Bhaskaran. Hey Baz, good to see you. Is there a price list for your CAD-CAM and fabrication service? We absolutely do have that. That is something that we can send to you on request. So if you'd like to send an email through to info@massonshealthcare.com.au, we can absolutely help you out with that there. Those for fabrication services, and then for CAD-CAM, we can have a bit of a chat about what your goals are and provide you a tailored solution with pricing from there.
Great, Louis. Thank you.
No worries.
Thank you all for attending, and thank you, Louis, for that presentation on building a CAD-CAM service model. Thank you.